Section 6.6 brings us to the last operation that we need to do with our radicals. Remember, we simplified them, then we did addition and subtraction, multiplication was the last one, and now we are on to division. So before we can divide anything, we need to remember our simplified forms. So remember the rules that we had before. Your radicand has no factor raised to a power greater than or equal to the index. Hopefully we're all good with that. The radicand cannot contain a fraction, which remember is division. And then no radicals in the denominator of a fraction can happen. So again, division. So we're going to be focusing on 2 and 3 a lot today. So here's another property. This is the division property of radicals, and it's basically exactly the same as the multiplication property of radicals. You can take two things that are dividing, and you can split them up into two different radicals, one on top, one on bottom. And then remember that this not only works forwards, but it also works backwards. You can combine them back into one giant radical. So let's start with some easy problems, where we're going to use that division property to simplify some things. So the very first one, I have a to the 6th power divided by b to the 4th power, and it's all square rooted. So first thing you should check for is, can you simplify stuff on the inside? Top is an a, bottom is a b, so we can't simplify. So we're going to use the rule that says that I can split these things up into a to the 6th divided by b to the 4th, and they're both square rooted. So now we can take the square root of both of these. Remember, this is a 2 out here. So you need groups of 2 to leave. A to the 6th can make 3 of those groups, and b to the 4th can make 2 of them. And then we can't simplify this, but it's totally okay to have fractions as long as there's no radicals involved. So let's do the next one. First of all, see if you can simplify what is on the inside. You have 81 y to the 5th divided by x cubed. Since everything's different, we can't combine it, so that means we're going to split it up. So, let's see, we have the cube root of 81 y to the 5th, and that is divided by the cube root of x cubed. The bottom's pretty easy, so let's do that first. You need a group of 3 to leave, and x has exactly one group of 3. So let's look at the top. 81 is not a perfect cube, but we can break it up. 81 is really 9 times 9. Both of these 9s can be split into 2 3s. And remember, you need a group of 3 to leave the house because it's cubed. So we can make one group of 3 that we can take out, and then there's going to be 1 3 that's left over inside of the cube root. And then with our y's, we have 5 of them there, so I can make one group that can leave. And then there's going to be 2 y's stuck in the house. So before we box this up, make sure it meets all of our conditions. This 2 right here is smaller than the index of 3, so we're good with that. There is no fraction inside of the square root, so we're okay with condition number 2. And then finally, there are no square roots in the denominator. So that means that we are done. So now let's do a backwards one. This one down here in example 2, I have the 4th root of 8p to the 7th divided by the 4th root of p cubed. So when I'm looking at both the top and the bottom, I can't simplify anything. I can see that I could take a group of p out of the top, but it's not really going to get me that far. So what I want to do next is turn this into one big 4th root, not square root. So then we have 8p to the 7th divided by p cubed. We can use that rule to combine things back. And now, when we have all of this fraction inside of here, we can see that p to the 7th divided by p cubed just gives us p to the 4th. So then we have the 4th root of 8p to the 4th. Much better, there's no fraction now, and we need to see if we can factor anything out or take anything out. If we break up 8, we get 2, 2, and 2. You need 4 people in order to leave. 8 only has 3, so the 8 needs to stay in there. But the p, since you have 4 of them on the inside and it's the 4th root, you can take 1 out. So we get p times the 4th root of 8. We're done because we do not have any fractions in there, and then 8 didn't have enough for anything to leave. So now to the hard part. We always save division for the last thing that we do because it is so much more difficult than addition, subtraction, and multiplication. The third condition that we need to have for our radical expression to be simplified is that we cannot have a square root in the denominator. So if you look at this problem right here, I can't simplify it the way that we did before. I can't turn that into the square root of 6 over 3. Can't take anything out. Can't do anything with it. So what we know so far won't work. So that brings us to this new thing that we're going to do called rationalizing the denominator. Remember, the denominator is the bottom part, and rationalizing means turning it into a number that's not a messy square root. So in order to do that, we need to think back to what we know about square roots, cube roots, and all of that good stuff. So look down here. Remember that if you have the square root of something squared, you just get the thing in the middle. If you take the cube root of something cubed, you just get the thing in the middle. And on and on and on and on and on. So what we need to do is figure out what we need so that we can take square roots or cube roots and get nice rational numbers, nice pretty numbers. So the first thing we're going to do is just figure out what we would need. So the very first problem, problem A, I have the square root of A times the square root of something is going to allow me to take the square root of it. So if we rewrite this, we have the square root of A, and I want to somehow rationalize this number. That means, because it's a square root, that I need 2 A's. I would have to multiply it by another square root of A, so that we get the square root of A squared, which simplifies to just A. A is a rational number, doesn't have a square root. We can do the same thing with C. We start with the 4th root of 2z cubed. I want to make this something that I can take the 4th root of. So that means I need to have 4 2's and 4 z's. 2's are not even close. I only have 1 of them. So I need to multiply it by 3 more 2's, or 2 times 2 times 2, so we can write it as 3 cubed. And then we only need 1 more z, so z to the first power, or just z. And when we multiply these two things together, we get the 4th root still. 2 times 2 cubed gives me 2 to the 4th. Z cubed times z gives me z to the 4th. And now I can rationalize these. The 4th root of 2 to the 4th is just 2, and the 4th root of z to the 4th is just z. Now, I know this is kind of confusing, but let's do it with an actual problem. We're going to do 2 different types. We're going to do it with 1 term in the denominator. Those are pretty easy. And then we're going to do it with 2 terms in the denominator, and those get pretty confusing. So this first one here, I want to simplify 5 divided by the cube root of A. Remember, in order for anything to leave the cube root, it needs to have 3 people. Right now, A just has 1. So I need to multiply by the cube root of A squared, because I need 2 more A's. And because this is a fraction, I can't just go multiplying it by whatever I want. I have to multiply the top and the bottom by exactly the same thing, because we know that this is really just multiplying by a big giant number 1. And it's totally okay to multiply something by a giant number 1. So on the top, we would end up with the 5 on the outside times the cube root of A squared. And then in the denominator, I would end up with the cube root of A cubed. And the awesome thing about our denominator now is that it simplifies to just a plain old A. And it's, again, okay to have a fraction as long as there's not 1 in the square root and there's not 1 in the denominator. Let's do another one. This one's actually easier than the last one. but it involves simplifying at the end. So I have 6 divided by the square root of 3. So in order to get rid of that square root, I would need 2 3's. Since I only have 1, I'm going to multiply it by another square root of 3. Remember, whatever you do to the bottom, you have to do to the top. So on the top, I end up with 6 root 3. And on the bottom, square root of 3 times square root of 3 is the square root of 9. And hopefully you've caught on, just like we've done before, that this is like the square root of 3 squared. So the square and square root cross each other off, and we are left with just 3, the number underneath. And then double check to make sure that you cannot simplify anymore. These numbers out here can be simplified. 6 over 3 is just 2. So we end up with 2 root 3. No more fractions, nothing in the denominator. We have simplified expression. You can type these in your calculator to ensure that they're exactly the same thing. 6 divided by root 3 is the same thing as 2 times root 3. Let's do the next one. Example 6. If I want to simplify that expression, since it's all underneath the square root, the first thing I'm going to do is check to see if I can simplify the top and the bottom. Y to the 5th divided by 7 can't be simplified, so my next thing I'm going to do is break it up. So the square root of y to the 5th divided by the square root of 7. And then see what I can simplify. So if I take the square root of y to the 5th, I can take out 2 groups of 2 y's, and then I'll have 1 y left in there. But I can't do anything with this square root of 7. We can't leave it down there because it's not simplified just yet. So I need to rationalize the denominator. I need to get rid of that square root of 7. And just like the last problem, because it was a square root, that means I need 2 7's. So I'm going to multiply the top and bottom by the square root of 7. On the top, we have numbers on the inside and numbers on the outside. So remember, we just multiplied the numbers on the outside together, so y squared. And then the numbers on the inside are y times 7. So we get 7y on the inside. And again, hopefully you've caught on that square root of 7 times square root of 7 is just 7. You get the square root of 49, which gives us 7. Before we're done, make sure that you can't simplify. Y squared and 7 don't have anything in common, so we can't simplify those. Make sure you don't simplify the 7 on top and the 7 on bottom, because one is inside the square root and the other is not. And then the last thing to check, can you do anything with the square root of 7y? And because we can't take anybody out, we're finally done.